Hey guys, this is part 3 and we're doing paper 3H from June 2011 for math. Okay, so we left off with question 17. Question 17 says that there are 7 counters and they're drawn over here. And this guy Ali, he puts the 7 counters in a bag, then he takes at random a counter from the bag and does not replace the counter. Now, he does not put back the counter in the bag. I want you to remember that. And then he takes a second counter from the bag. So for the first question, they're asking you to calculate the probability that the number on the second counter is 2 more than the number on the first counter. So 2 more, meaning plus 2. So the only possibility of that is actually getting a 2 at first and then getting a 4. Because the second counter would then be 2 more than the 2. Alright? So that's the only possibility, that's the only likely event that could happen. Because there's no other numbers over here that are 2 more than the other number. So the only possibility is first getting a 2, then getting a 4. So that's the event, right? In which this situation will occur. Okay? So first of all, you have to calculate the probability that in the first counter, he's going to get a 2. And that is 1 out of 7. Then, since it's one whole event, you're going to multiply it by the probability for the second counter being a 4. And that is 3 out of 6, because technically, one counter has been removed, meaning there's 6 counters left, and there's there's actually 2, my bad. Actually, that's my bad, sorry. There's actually 2 4 counters. So there's 2 4 counters to choose from out of 6 total counters, so it's 2 out of 6. So it's 1 over 7 times 2 out of 6, which is 2 out of 42. And if I divide both the top and bottom by 2, I will get 1 out of 21. So that is the probability that the second counter will be two more than the first counter. Okay, so the second question, 17.2, is asking the probability that the number on the second counter is 1 more than the number on the first counter. Now, there are many possibilities of this. So first of all, you could pick one event that could occur. I'll call it E1, event 1. I'll call it E1. Okay, that means event 1. You get a 1, and then the second counter is a 2. Another possibility that could happen, E2, could be you get a 4, and then a 5. So those are the 2 events that could occur. So we'll calculate the probability of each event. So first of all, for this event, right, the probability of first getting a 1 is actually 1, because there's only one counter, 1 out of 7, multiplied by, there's 1 2 counter, so 1 over, but now there's 1 less 1 counter, so there's 6 counters now, so 1 over 6. And the probability of this event is actually, the probability of getting a 4 first try is 2 out of 7. And this is a completely new event, so that means we have 7 counters in the bag. Just remember that. Since it's a completely new event, you start off fresh. Okay? Multiplied by, but now there's 1 less counter and there's 3 5 counters. So 3 over 6. Because there's 1 less counter. Okay? Okay, so now these are the 2 possibilities that could occur, these 2 events. So to calculate the total probability, all you have to do is add these 2 events. So 1 over 7 times 1 over 6 plus 2 over 7 times 3 over 6. So that becomes, it simplifies to 1 over 42 plus 6 over 42. And if you write that as one fraction, it becomes 7 over 42. Now if we divide both the top and the bottom by 7, because they're both divisible by 7, we're going to get 1 over 6. And that is the total probability that the second counter will be 1 more than the first counter. Alright, question 18 is asking you to calculate the length of BD, we'll call it X, which is this length here, and correct the 3 significant figures. Now, first of all, to do this question, you need to know something called the sine rule. And I've written the sine rule over here. So in any triangle, if you have, let's say, a side A, and the angle opposite to it, capital A, and you have a side B and an angle opposite to it, capital B, or you have a side or you have an angle C and a side opposite to it C, the ratios of the length and its opposites and the opposite sine of its angle is equal. So let's say B over sine B. So the ratio between this and the opposite angle, right, that is equal to the ratio of this and its opposite angle. And this applies to all opposite angles and sides in a triangle. So now knowing this, we can solve this question. Alright, so first of all, look at what we're given. We're given this triangle here, and we're given a length here. Right. Now, first of all, what we could do is we could find this angle over here, and that's pretty simple because angles on a straight line, as you can see, add up to 180 degrees. Simple geometry. So that means that this angle over here is equal to 180 minus 51, and that is 129 degrees. Okay, so now here's where the sine rule comes in handy. So for this triangle over here, which over here, we have the side opposite to it, which is 47, and we have the angle opposite to the side, which is 129. And we could actually possibly find this side, and that'll help us find this side in the end. So how are we going to do this? So we're going to do 47 over 129, sine 129 is actually equal to the other side, which we'll call it y over here, this side, over sine of 32. Now, if you just multiply both sides by sine 32, you're going to get y is equal to 47 times sine 32 over sine 129. And so this y over there is equal to 32.048, and like it keeps going on. Okay? So that means CD is equal to 32.048. Okay, so now we know that CD is 32.048. We know the angle over here, and we can notice that this is actually a right angle triangle. So we can apply our SOHCAHTOA rules. I hope you guys remember them. SOHCAHTOA. So I've just quickly written them out for you. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan of the angle equals opposite over adjacent. So if you look at this triangle, what we've got here is the hypotenuse, because the hypotenuse is the side opposite to the right angle. And we want to find out x, which is the adjacent side, which is the side where both the right angle and the other angle lie on. So we have the adjacent and we have the hypotenuse. So which function relates both of those sides? And it is the cosine function. So that means we can construct a small algebraic equation. So cosine of the angle, which is 51, is equal to the adjacent side, which is x, or BD, over the hypotenuse, which is, we discovered in the previous part of this question, 32.048. All you got to do is multiply both sides by 32.048, and you're going to get x is equal to cosine 51 multiplied by 32.048, and so x is equal to 20.1686 blah blah blah, which just simplifies to 20.2 centimeters. Okay, question 19 is about proportionalities, and they tell you that P is directly proportional, this is the symbol for proportional, to the cube of Q, meaning Q cubed. Alright? So, they're asking you to find a formula for P in terms of Q. Now if I put this algebraically without this stupid sign over here, what it would actually look like is P is equal to K times Q cubed, where K is a constant. K can be anything, 1, 2, 1 over 10, it can be anything, it's just a constant, and it's just this, like, because they're related by a scale factor or a number. So that's the first step, writing this small equation down. But we need to find out what the K is to develop a proper formula. So, they actually give you some tips over there, not tips actually, values, and they tell you when Q is 15, P is 1350. So all we have to do is substitute these values into this equation here, and we're going to get 1350, replacing p by 1350, is equal to k times 15, replacing q by 15, 15 cubed. So what we're going to get is 1350 is equal to 3375k. Now dividing both sides by 3375, we're going to get k is equal to 1350 divided by 3375. And this simplifies to 0.4. So we have a value of k, and we have our original equation. So all we got to do is replace the value of k. So what we're going to get is p equals 0.4 times q cubed. And that is your formula. Okay, question 19b is really simple. They're asking you to calculate the value of p when q is 20. So you've already found out your equation, and you know you want to find out the value of p, and you know that q is 20. So all you have to do is substitute q into this equation. So you're going to get p equals 0.4 times 20 cubed. So p is equal to 0.4 times 8000, and so p is equal to 3200. Okay, question 20 has said that x equals 8 times 10 to the power of n, where n is an integer and a is in between root 10 to 10. So it's equal to or greater than root 10, but should be less than 10, meaning it's in standard form. So you got to find an expression for x squared. So x squared means that it's a into 10 to the power of n, the whole squared. So when you square a number in standard form, what happens is this gets squared and this gets squared. So you're going to get a squared into 10 to the power of 2n. I'm hoping you know your exponent rules. They're pretty simple. When you're squaring something in between a bracket, you multiply the powers, which is in this case 1 and n over there. You multiply them by the thing is to the power 2. Okay? So you have to give your answer in standard form. Now, if you look at this expression actually, a squared, they've told you over here that a is between root 10 and 10. So if you were to do, like let's say if a was root 10, and you did root 10 squared, yeah? What would happen it would now be 10, so a would now be 10. But that means that it's not in standard form, because in standard form, you have to have it at least between 1 and 10. You have to have your value, or whatever you have to have, it should be in between 1 and 10. So it should be like 1.0 or 2.2 into 10 to the power of blah blah blah. It cannot be 10 into 10 to the power of something. So, and that would apply for all a squared, because all a squared would be 2-digit numbers. Because let's say if it should be less than 10, so if it was 9, let's say, 9 squared, we know that it would be 81, which is a 2-digit number. Okay, so all a squareds would be 2-digit. But the thing is, we want to get into 1-digit form. So how do we do that? All we have to do is actually divide it by 10, because like let's say a was 9, so 9 squared, it would be 81. If we divided that by 10, we would get 8.1. Okay? So what we do is we divide a squared by 10, so we get a squared over 10. But that completely changes the whole value of the equation technically, because now a squared is actually, the whole number is actually much lower. So in order to make it the same number, we just do 10 to the power of 2n plus 1. Because for example, if we add 81 into 10 to the power of 3, and we want to make it into standard form, we would divide this by 10 to get 8.1, and then we would just add another power here, so 10 to the power of 4. And in theory, they're actually the same value. Because if we were to expand this out, this one, we would get 8, 1, 1, 2, 3. And if we were to expand this out, we would still get the same value. Correct? So all we do is we add an extra power to 10. And so your answer is a squared over 10 times 10 to the power of 2n plus 1. Because we're adding an extra power to make up for this over 10. Alright, so question 21 has given you this rectangle, and within it there's this quadrilateral PQRS. And in the first question, 21a, they're asking you to show that the area is equal to 2x squared minus 18x plus 80. They're asking you to show this. Okay? So what happens is, now look closely at the whole shape. Okay? If you really look closely, you'll notice that there's actually 4 triangles. And they're all identical triangles. Okay, now you've been given their lengths as, some of them have the length x, correct? And you've been given the length of, actually they're not all identical triangles, sorry, these two are identical. And these two are identical, my bad. Okay, so you've been given lengths 8 and 10 of the whole rectangle, and you've been given small lengths x of the triangle, of some of the triangles. Okay, so what we need to do is we need to find out the other lengths of the triangles. Okay, so let's do that. So if you look at this whole length is 8 centimeters, right? And this length is x centimeters, meaning this length should be 8 minus x. And the same for this side, so 8 minus x. Now again, if you look at this is 10 centimeters, this is x centimeters, so this must be 10 minus x. And the same for the top, 10 minus x. Okay, so now we've established all the sides of the triangles, we can actually determine the total area of the quadrilateral, this quadrilateral here. So, now how are we going to do this? First of all, if you actually look at the whole rectangle, if you take the whole area of the rectangle, one way we could actually solve the area of this would be to take the whole area of the rectangle and subtract each of these areas. So subtract this, subtract this, subtract this, and subtract this, and we would end up with this area. Okay? So that is one way we're going to actually do it. So we're first going to calculate the total area of the rectangle, and that is length times width, which is 8 times 10, which is equal to 80 centimeters squared. Okay? Then we're going to calculate the area of this triangle, and since it's the same, we'll just multiply this area by 2, because they're two same triangles. Okay? So the area of any triangle is half times base, which is x in this case, times height, which is 8 minus x, and we multiply this all by 2. That'll give us the area of this triangle as well as this triangle. So the 2 and the 2 cancel, so we get 8x minus x squared. Okay? So it's 8x minus x squared. Sorry if I'm erasing because I don't have much space here. Okay, then I'm going to calculate the area of, sorry, I'll just erase these off. These triangles here. So this triangle as well as this triangle. Okay? So again, it's half base times height, so it's half times x times 10 minus x, and since there are two of the triangles, multiplied by 2. Again, the 2 and the 2 get cancelled, and you end up with 10x minus x squared. So it's 10x minus x squared. So now we have all the areas of we have the areas of the triangles, and we have the areas of the rectangle. So all we have to do is take the area of the rectangle and subtract the area of the triangle and subtract all the triangles. So all we have to do is do 80 minus 8x minus x squared minus 10x minus x squared. And notice how these are in brackets, because when you're subtracting the whole number. You're not just subtracting minus 8x. Okay, you're subtracting the whole number. Okay, and that'll give you 80 minus 8x plus x squared, because minus and minus make plus, minus 10x plus x squared. And what you're going to end up with, I'll write it up here, is actually plus x squared gives you 2x squared, minus 8x minus 10x gives you minus 18x, and plus 80 gives you plus 80. And that is the area. Just write that area is equal to that. So you found the area. in terms of x. Okay, question B21B1, they're telling you for area equal to 2x squared minus 18x plus 80, find dA over dx. Now I've written this on the side. This is differentiation, and it's pretty basic differentiation. So let's say if you had a equals x to the power of n, like over here. So when you differentiate dA over dx, so dA with respect to the x, right? What you're going to do is this n, where x is to the power of, will come down here, so it'll become n multiplied by x, and the power will get subtracted by 1. Okay? So that's how general differentiation works. Now, if you have a equals n, where n is any normal number, right, and you're trying to differentiate a with respect to x, this n will actually turn to a 0, so it'll just be cancelled out. So now knowing this, we're going to differentiate we're going to do dA over dx. Okay, so for the first one, what's going to happen is the 2 is going to come down here and get multiplied by the x. So it's going to become 2 times 2x and to the power of 2, but that'll be subtracted by 1 according to this rule here. And then minus 18. X, 18 multiplied by 1, because this is actually to the power of 1. So it gets multiplied by 1 times x to the power of 1 minus 1. And plus 80 will just become 0 since it's just a normal number. So what you're going to get is 4x minus 18 x to the power of 0, because 18 multiplied by 1 is 18, and x to the power of 0 is just 1, so it just becomes 4x minus 18. So that is dA over dx. Okay, so you have dA over dx equals 4x minus 18. For 21b2, they're asking you to find out the value of x for which area is at a minimum. So when you want to find the area at a minimum, what you have to do is you have to actually make dA over dx equal to 0. Okay? So that means that dA over dx is equal to 0, and dA over dx is also equal to 4x minus 18. So that means that 4x minus 18 is equal to 0. And we just solve for x, so we're going to add 18 on both sides. We're going to get 4x is equal to 18. Divide by 4 on both sides, we're going to get x equals 18 over 4. And so x is equal to 4.5. So area is at a minimum for 4 over 4.5x. Okay, for when x is equal to 4.5. Now for 21b3, you have to explain how do you know that the area is at a minimum for this value of x. Now to do that, you actually have to look at the original equation, and the original equation is area equals 2x squared minus 18x plus 80. Now, when you have a quadratic equation, and let's say the first, you have to look at the first term over here. So if the first term, let's say, is x squared, so it's positive x squared, the graph will actually have a shape like this. But if it was negative x squared, it would have a shape like this. Okay? And technically, that means that this would be a minimum point, and this would be a maximum point. So, since the coefficient of x squared, the coefficient being this small number here, so the coefficient of x squared is positive, correct? Is positive. That means that it's a minimum. Because there is no maximum possible in this kind of shape of graph, because there's no maximum possible. If it was negative x squared, it would be a maximum, but since it's positive, that should mean that the area is at a minimum value, because there's only a minimum possible. Okay, we're done with part 3. Sorry if this is taking very long, it's a pretty difficult paper. And please comment, rate, and subscribe, and yeah, please watch the next part.